In our final video in the series regarding motion of objects within the solar system, we're going to focus entirely on the motion of artificial satellites around and in the vicinity of Earth. So recall that a satellite is simply any object that has an orbit around the Earth, and an artificial satellite is a satellite that orbits the Earth that was constructed by humans. The first and one of the most famous examples of which is the satellite in this picture, launched into orbit all the way back in 1957 by the Soviet Union, which we call Sputnik. Now, since 1957, our satellite technology has developed very significantly to the point where we can actually launch satellites into very specific orbits around the Earth that assist in whatever their function is. So many satellites, not all, use what we call a geosynchronous orbit around the Earth. Now, if we break this word down, obviously the geo prefix at the beginning tells us that these satellites are moving around the Earth, but the root of the word synchronous implies that they are doing something at the same rate as the Earth. So if we take this satellite in our diagram, and if we say that this satellite is pointed straight down and looking at where we are in southwestern Ontario, if we were looking back up at this satellite as it orbited around the Earth, it would look like this satellite was staying in exactly the same position around Earth. Of course, it isn't, because it's in orbit around the Earth, but the reason why it appears as though it's holding the same position is that this satellite is moving synchronously to the speed of the Earth's rotation, meaning that as the Earth rotates, because the satellite orbits at the same speed, this is why, to us, looking up at the satellite on Earth, it would look like the satellite is holding position even when it isn't. Now, this particular geosynchronous orbit is a specialized geosynchronous orbit, which is what we call a geostationary orbit. So recall that the word stationary means not moving, so this is a bit of a misnomer, because as we've established, even if it doesn't look like the satellite's moving, it definitely is. But we call it a geostationary orbit because the satellite maintains the same orbital pattern above the center of the Earth, which is what we call the equator. Naturally, this satellite is what we use to study conditions around the center of the Earth, such as weather, which is what we're going to take a look at now. Now, satellites, as they have been developed, have many, many different functions depending on what the goal is. So all that we're going to do here is look at some of the major functions of satellites that we've launched into orbit, starting with probably the most well-known example, satellites that are used in assisting human communications. Now, some people that get their television signal from a satellite depend on communication satellites to bounce a TV signal off a satellite from one location, and then the satellite retransmits it to a different location. We can also use satellites for phone communication. Phones that use satellite signal are literally called satellite phones, and it's also used to bounce radio signals off so that you can listen to radio signals from across the world. Closely related to communication satellites are what we call navigation satellites, which are simply satellites that are used to help people find directions in travel. Now, individual travelers will be most familiar with something called GPS. GPS stands for Global Positioning System, which is used in cars in order to help find directions. Every time that you are searching for directions using Google Maps, you are using data that orbital satellites collect when they look down on Earth and monitor traffic patterns and use the roads in order to help you find the best route. But it can also be used in order to help air traffic controllers help planes to land properly. All of these depend on navigation satellites. If you remember the example of satellites used above the equator to study weather patterns, this is yet another example of geosynchronous orbital satellites fulfilling a specific role. Weather satellites can be used to track the amount of rainfall that specific areas are going to get, or snowfall in colder areas, and also help to monitor the Earth's temperature, which is becoming increasingly important as we study the effects of global climate change. If we move to space exploration, however, astronomical satellites become very important as they allow us to literally look deep into space in order to study star systems or even planets that are far, far away from Earth. This is probably the most famous astronomical satellite ever launched. This is, of course, the Hubble telescope, which is basically a telescope in satellite form that allows us to look into deep space and learn about galaxies and other planetary bodies that are far, far away from Earth. The next type of satellite only exists theoretically. We have not actually fully developed the technology to do this. However, again, because of global climate change, satellites that are used in what we call solar collection are going to potentially become very important. So the job of a solar collector satellite is basically the same job that solar panels or a solar farm have on Earth. Their job is to use the photovoltaic cells in these large wings that it has here in order to absorb sunlight, and then the core of the satellite takes that energy that absorbs and transmits it down on Earth in the form of microwaves or in the form of some sort of radiation in order to be used on Earth to produce electricity. And again, because these satellites aren't even located on Earth, the emissions in terms of contributing to global climate change will be completely non-existent. The part that prevents us from using this technology is figuring out exactly how we get the energy that is absorbed by the satellite down to Earth and still make it usable. Now, the final category of satellites are not normally considered satellites in everyday speech. This is, of course, an example of a space station, but following the definition of an artificial satellite, a human-constructed object that orbits around Earth. Technically, space stations such as this one, which is the ISS, the International Space Station, technically fall under the definition of satellites. So the job of a space station is a satellite that actually has a human crew that lives on the satellite in order to conduct research, which can only be done in deep space. For example, what are the long-term effects of a human crew actually living in deep space? What are the conditions that are needed to grow plants in deep space? And other research that is necessary for human travel from Earth and beyond to other planets. This concludes our video series on planetary motion. In the final video series of the astronomy unit, we're going to look specifically at stars, the life, the birth, the growth, and the death of stars, including that of our own sun.